So IBM just dropped some absolutely massive news. They've unveiled not just a couple of new processors, but a real concrete plan to build a machine that could literally change the world, a fault-tolerant quantum computer. So what does this quantum leap actually mean for all of us? Let's break it down.
Okay, let's start with the big, kind of mind-bending question. What if we had a computer so powerful that it could solve problems we currently think are, well, impossible? We're talking about things like discovering life-saving new medicines, designing revolutionary new materials, or completely transforming the world of finance. You know, the kind of problems that are way beyond what even the fastest supercomputers today could ever dream of tackling. That, right there, is the incredible promise of quantum computing.
And that promise is exactly why all the big players are pouring billions and billions of dollars into this race. It's not just about faster computers. It's about a whole new era of computation.
And let's be super clear here. We're not talking about a machine that's just a little bit faster than your laptop. No, this is a fundamental, game-changing leap. It's a tool that could unlock breakthroughs we can barely even imagine right now. But, and this is a big but, getting there has been anything but easy. Because for all of its incredible world-changing potential, quantum computing has a massive Achilles heel. The reality right now is that these machines are, well, they're incredibly fragile and prone to making mistakes. To really get why, you have to look at the basic building block, the qubit. Now, a normal computer bit is simple, right? It's either a 1 or a 0. But a qubit, thanks to the weirdness of quantum mechanics, can be a 1 and a 0 at the exact same time. This quantum superpower is what makes it so powerful, but it's also what makes it incredibly delicate and fragile. And that brings us to the central challenge facing this entire field. The very quantum magic that gives these computers their power also makes them ridiculously sensitive. The tiniest vibration, the slightest change in temperature, what scientists call noise, can throw off the whole calculation and create errors. Fixing this error problem has become the holy grail for everyone in the space, from IBM to Google to Amazon.
So how in the world do you solve a problem that's baked into the laws of physics? Well, IBM has come up with a really clever new way forward, and the inspiration actually comes from a device you probably have in your pocket right now.
Seriously, think about making a phone call. Your phone is constantly running these sophisticated algorithms to filter out all the background static and noise so you can actually hear the person on the other end. IBM has basically adapted that same idea for quantum computing. They're using a powerful algorithm to filter out the quantum noise to get a clear, correct answer from their calculation.
So how does this actually work? It's this really cool three-step hybrid process. First, the super complex calculations get run on the quantum chips. At the exact same time, powerful classical computer chips are running that clever error correction algorithm. And then finally, the two results are combined to produce one single, reliable, accurate answer. This whole process is the key to creating what's called a fault-tolerant quantum computer, one that can basically catch and correct its own mistakes as it goes.
And hey, don't just take my word for it. Experts are really taking notice. Mark Horvath, who's an analyst over at Gartner, called the idea very, very clever. But as he points out, the most exciting part isn't just the idea. It's that IBM is actually moving this from theory into real physical hardware.
And that, my friends, brings us to the big reveal. This whole cell phone-inspired solution, it's not just a drawing on a whiteboard anymore. IBM has actually built the chips to prove that it can work. This is where the rubber meets the road.
So first up, we have an experimental processor they've named Loon. The best way to think of Loon is as the pathfinder. It's that crucial first step that proves all the different complex pieces needed for this error correction system can actually be built and can work together on a single chip. It is, quite literally, the proof of concept. And then there's Nighthawk. If Loon was the pathfinder, Nighthawk is the workhorse. This is the processor that's actually going to be available for researchers to use by the end of 2025. This is the chip that will let them start really aiming for quantum advantage. And that's the tipping point, that crucial moment where a quantum computer can finally solve a useful problem better or faster than any classical computer on Earth. And the specs on this thing are pretty impressive. Nighthawk is packing 120 qubits and 218 of these next-gen connectors. But the number that really jumps out is the 30% improvement in circuit complexity. Now, what that means in plain English is that it can handle way more sophisticated and difficult problems than anything that came before it. It's a major step up in what's actually possible. So, you have to understand, these new chips aren't just one-off science projects. They are critical steps in a very clear, very ambitious roadmap that IBM has just laid out for the rest of the decade. And their plan is super concrete.
by the end of 2025, Nighthawk gets into the hands of users. Then the big goal for 2026 is to use that chip to actually demonstrate quantum advantage for the first time. And all of it is building toward the ultimate prize, delivering the world's first large-scale, genuinely fault-tolerant quantum computer by 2029.
And IBM isn't just focused on the hardware. They're pushing on all fronts to make this happen. They've got new software that boosts accuracy by 24%. They're upgrading their manufacturing to basically double their development speed. And maybe most importantly, they're launching an open community tracker. This will let anyone transparently test and verify claims of quantum advantage. It's a huge shift from just saying you've had a breakthrough to openly proving it to the world.
So, there you have it. IBM has just laid out a clear map, a pathway from the noisy, error-prone machines of today to a truly useful, fault-tolerant quantum computer by 2029. And that brings us back to the ultimate question. Now that we finally have the map, where exactly will this incredible new technology take us?